Hi, boys and girls. Miss Kathy here with another episode of Stupendous Summer Science. And we are coming at you today from indoors here at Shaler North Hills Public Library because it was kind of wet and rainy outside. So we are going to do the story from indoors today. And the story today is Newton and Curie, the Science Squirrels. So let's see about these scientific squirrels. Never heard of such a thing. Do you ever hear of squirrels being scientific? So there they are in the tree, and down comes an apple and goes bonk. Newton was sitting under a tree when an apple bounced off his head. Why did that apple fall down and not up? He asked himself. From that moment on, the little squirrel began to wonder how the world worked. I wonder why that swing works the way it does, Newton said to his little sister Curie as they watched children on the school playground. I don't know, said Curie. Let's go find some nuts to eat. I'm hungry. Oh, all right, Newton said, but he couldn't stop thinking about the swing. Later that day, Newton jumped up on the swing the way he'd seen the children do. He sat for a while, wiggling and rocking, but the swing didn't move. What are you doing? Asked Curie. Don't you wonder why a swing goes back and forth? Newton asked. Why does it go so high sometimes? And why does it work so easily for the children when it doesn't work for me? Oh, let's not think about that now, Curie said. Let's play tag. The next day, Newton passed by a classroom window. Today we'll learn about simple machines, the teacher said. We'll study gravity and force, and we'll learn about experiments. As Newton listened, he had an idea. He decided to try an experiment of his own. Newton looked around his neighborhood until he found what he needed to create his own swing. What are you doing now? Asked Curie. I'm testing an idea, Newton said. That's called an experiment. Pumping my legs gives me the force to move forward and see how gravity brings me back down again. I want to try, Curie said. And she did. What's this? Asked a pair of robins who were building a nest in the tree. It's science, said Newton. Curie laughed. And it's fun. The next day, Newton watched some children rocking up and down on the seesaw. He longed to try it for himself. At dusk, he went and sat down on one edge of the board. What are you doing now? Asked Curie. Come and sit on the other side, Newton said. We'll do an experiment. Curie sat down, but the board didn't budge. She jumped up and down, but there wasn't enough force to make the seesaw move. The board is too heavy and we don't weigh enough, said Newton. Humans weigh more than squirrels, so they have more mass, Curie frowned. Maybe science isn't for squirrels. In the morning, Newton hurried to the branch above the classroom window. He studied the whiteboard and listened to the teacher explain another simple machine. Newton could see that a lever and a fulcrum looked a lot like a seesaw. That gave him an idea. It's back on her board. The lever and the fulcrum is the triangle underneath it. Newton searched his neighborhood until he found what he needed for a squirrel-sized seesaw. "I bet you're making something," said Curie. Newton smiled. "It's another experiment. The board is a lever, which increases the force we need to go up and down. The rock is for balance. It's called a fulcrum. If we put the rock at the center of the board, we can balance our weights on either end. Gravity pulled us down, and we use the force of our legs to push off again." "Whee!" said Curie, "and it's fun." "That does look like fun," said one of the robins. "It is," cried Newton. "How is your nest?" "It's all finished," said the bird, "and we have 4 beautiful eggs. You should come take a look." Newton and Curie went to visit the birds in the tree. "You're so lucky you can fly," Curie said. "Gravity doesn't mean anything to you." "Gravity affects everyone," Newton said. The next morning, Newton and Curie went to listen at the classroom window. "With a wheel and a rope," the teacher said, "you can make a pulley. A pulley makes it easier to lift heavy things." Curie said, "If we had something big we had to move, that simple machine would be great. But I can carry everything I need in my own paws." That afternoon, Newton and Curie came to watch the children play. But it was a windy day, so the children stayed indoors. Just as the squirrels turned to go, they heard a terrible cracking sound. A big branch snapped and toppled to the ground. "Help!" cried the robins. "Our nest has fallen!" "Our eggs are all right," the birds cried, "but we've got to get them back into the tree where they'll be safe." "I've got an idea," Newton said. "Just wait here." Newton and Curie raced to the classroom window, which was open just a crack. The children were off at lunch, but they could come back any moment. "We could use those spools and some string to make a pulley," Newton said. "But how are we going to get in there?" "I've got an idea," said Curie. "Let's find a stick to use as a lever and pry the window open so we can get inside." The squirrels found a piece of branch and slid one end into the opening. Then they jumped and jumped on the lever until the window opened, just enough for them to scramble inside and get the supplies they needed. Back in the tree, Newton fit the spool over a small but sturdy branch. Curie bundled the bird's nest into a cloth and tied it to a long piece of strong string. "We're making a pulley," Newton said to the birds as he pulled the end of the string up the trunk. "We'll use it to get your nest back into the tree." "Please be careful," cried the birds. Once he'd wrapped the string around the spool, Newton grasped the free end of the string and jumped from the branch. Gravity pulled him down, but it wasn't good enough. The nest was too heavy. "I know what to do," Curie said, and she jumped onto Newton's back. Together, the 2 squirrels weighed enough to pull the string to the ground and lift the bird nest into the tree. Yay, Newton and Curie. The robins nudged their nest into a safe place. "Our experiment was a success," cried Curie. "The pulley worked," Newton shouted. "Soon our eggs will be ready to hatch," Curie said, "and your babies will learn to fly." "I wonder how flying defies gravity," Curie wondered. Time for a new experiment, Newton said. Science is fun. The end, except there's some facts in the back. These squirrels are not just named after funny words, they are named after famous people. I named the squirrel in my story Newton after Sir Isaac Newton, who lived a long time ago. He was a physicist and a mathematician who helped develop modern physics principles, including how things move. He's one of the most important scientists of all time. Marie Curie is named after, or the squirrel Curie is named after another famous scientist, Marie Curie, who also lived a very long time ago, and who won the prestigious Nobel Prize twice. She was a physicist and a chemist who conducted pioneering research on radioactivity, among many other things. And he said he hopes this book will develop a deeper interest in the world around you and in the scientific principles and laws that shape our environment. Wow, that's a lot of stuff. In this story, Newton the squirrel learns how to study the world, which is one of the meanings of the word science. He learns some of the basic law of physics. That's how things work. And we do experiments to test an idea, and they are behaving in this story, the squirrels are behaving like scientists. We did experiments on matter and energy in this book. And he tells you a lot more about what those words mean over on the glossary page. So, as you can see, science is all around us. And you can read about it in fun stories like Newton and Curie, brother and sister squirrels. And you can experiment with that, like we do with Stupendous Summer Science. So stay tuned because we have more experiments coming your way. Thanks for watching this part of the video. Now let's get on to the other part. Hi boys and girls, Miss Kathy here with another episode of Stupendous Summer Science. And today we are using items from your kitchen. And we have some tarnished pennies. And we are going to try to clean them with something you like to eat, maybe. Taco sauce. So we're going to rub some of this taco sauce on the backs of these pennies and see if we can get them a little bit cleaner when we leave them sit for a little while. How is something you eat going to clean off a penny, you may say? Well, that's what we're gonna find out. So we have covered them with the sauce, and now we are going to leave them sit for about 2 minutes or so and see what happens. So stay tuned, we will check right back. Let's check those pennies, and we have the ones that are covered with salt. So we're gonna brush off the salt, and I'm not really seeing any difference here on these pennies. Salt by itself does not seem to have done very much. Now we'll go to these ones that are soaking in vinegar. And I think these ones, dry them off here a little bit. These ones aren't looking a whole lot different either. How about with the tomato sauce? If we can find the penny underneath all that tomato sauce, huh? So wipe it off and see if that one looks any better. I can't remember which side was up. Looks like the top one may have gotten old. Okay, so this one had, oh, this one is a neat penny. Look at that. It's a, I wonder if this is a Canada penny. Let us find out here because it's got something different on the back. Look at that. This is a Canadian penny. I didn't even notice that at first. A lot of times they're used as American money, but I noticed on the back that it had leaves and not the Lincoln Memorial. So, but I still think that it's maybe a little better than it was. And the ones in the water, I'm thinking they don't look a whole lot different. So, which one do you think's gonna be the biggest change so far? Probably the tomato sauce and the vinegar. So let's do it one step farther and combine two of these ingredients together. So what we're going to do with the salt is add salt and vinegar to this tray. Except I have to turn it around to write it. Okay, then we're going to put vinegar and tomato paste together. Now I have to say I'm not using tomato paste, I'm using sauce because that's what I had open. And I actually didn't even use taco sauce, I used salsa because it has many of the same ingredients. So this is why you can do the experiment in many ways and experiment with things you have at home and not go out and run to the store and make special purchases. You can try it with what you have and experiment and see how it works. If that doesn't work, then maybe you do want to do a trip to the store run, but maybe you don't need to. Okay, so now we are going to try those combinations. Get the water out of here, that didn't work. So salt and vinegar. We're going to put some more salt on these pennies here and then add some more vinegar from our spray bottle here. Okay, now we have tomato sauce and vinegar. So let's put these back in the vinegar and we will add some tomato sauce on there as well. Spread that all around. There's both of those things in there. Hopefully working on the pennies. And then tomato sauce and salt. So we're going to rub those around in the tomato sauce. Get them covered up there. And sprinkle some more salt on the top. Okay, we're going to leave them sit. But while we leave them sit, we are actually going to do another experiment with, you guessed it, with pennies. And we are going to see how many drops of water we can put on one penny. How many do you think it will be? Let's find out. So we have a pipette and we are going to keep track of the number of drops here. So we're going to take some water up into our pipette and we're going to put 1 drop on. Well, it can clearly take more than 1. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, that one ran over the edge there a little bit sooner than I expected. Let's try it again and see if we can get a little bit more on than 14, because I think we can do better. Take our water up into our pipette again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 12. So, did you think we would get 12 drops on one little penny like that? It may also have to do with the slope of the table. If you're not on a perfectly flat surface, the water would tend to run one way or the other. Let's try it one last time. Use an entirely new and dry penny and see if we can beat, what did we have the first time? 14 and then 12, right? 13. Okay, my assistant says 13. See if we can beat 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Look at that. So that was better. I think one of the keys is to keep dropping it in the center of the penny instead of going to the edge, because then it is more likely to branch out. So why does that work? Why do we get so many drops on one penny? That is because of cohesion and surface tension. They are special because of hydrogen bonds. Hydrogen bonds are formed by the hydrogen atoms of one molecule being attracted to the oxygen atoms of another molecule. The cohesion and surface tension of water becomes apparent when the drops of water you add to the penny reach the penny's edge. Once the water has reached the edge, you begin to see a bubble or a dome of water forming on top of the penny. The bubble shape is the result of those water molecules clinging to one another in the optimum shape. That means the best shape for them. Just like the bonds on the surface of a blown bubble cling to each other and make the bubble shape. This is kind of like a bubble of water on top of the penny, and it kept getting bigger and bigger until it finally just the surface tension broke and it had to expand over. Facts about pennies. On the average, pennies can last for 25 years. And surface tension, when we talk about that, we're describing the cohesion between the water molecules. So let's go back to, at this point, that was another little penny experiment. Let's go back to our 3 test plates here and see which one is probably going to give us the best results. Dun, 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 dun. Okay. Salt and vinegar. Now they're looking pretty cleaned off here, I do have to say. Pretty shiny compared to what we started with, which was a penny that was more like that. We'll put that up on the edge there so we can keep track of which ones are which. Drying that all off there. Okay, tomato sauce and vinegar. I think we have pennies under here somewhere. There we go, our 2 pennies. Clean them off in the water a little bit here, and then we'll dry them off. Remember, if you actually do use taco sauce, it could kind of burn your eyes, so you want to make sure you wash your hands real good before you touch your eyes if you were doing it with any sort of food item, but taco sauce is extra. Okay, now we have these 2 pennies, which again started off more as, well, it wasn't quite that bad for sure.
Under your hand.
Under my hand, there's another one, she says. So started off like that and now looks like that. And then we have the ones with the salt and tomato sauce. So let's rinse those ones off and see what we get when we rinse those ones off. we just did. Now, where we have the Canadian one and our original American one. It worked a little bit on those ones too, but not so well as on the other ones, I don't think. So we have here vinegar and tomato sauce compared to salt and vinegar. And it may be a toss-up. Both of those, the key ingredient is the vinegar. By themselves, the salt and vinegar will do very little to remove the creating of copper oxide on the penny, but together they make a great cleaning agent, vinegar and salt. But there is salt in the tomato sauce, so that's why that one worked pretty well too. The salt dissolves in the vinegar solution and breaks down sodium and chloride, which go up to make the copper oxide. The chloride ions then combine with the copper in the penny to remove the tarnish from the surface. So the secret in taco sauce is the combination of the ingredients. Someone might argue that tomato paste is slightly acidic and may contribute in a small way to removing the copper oxide coating. But the real power ingredients are salt and vinegar, which is what we said. There is salt in the tomato sauce, so that's why that one did a pretty decent job too. But without salt, and certainly not without vinegar, you could not have nice shiny pennies like I do now. I'm all ready to go and spend my hard-earned pennies. Here we have comparison of some of our dirty pennies and our clean ones, and these ones got not too bad, but certainly not all the way clean like these 4 sample ones are. So, many experiments you can do with just a few cents, you may say. And that has been another episode of Stupendous Summer Science with Miss Kathy. Stay tuned for more.